Exercise 4D, questions 1 through 5. Question 1, safety regulations for wheelchair ramps mandate that the maximum gradient of the ramp should not exceed 0.08. So M must be less than or equal 0.08. Calculate the gradient of the triangular ramp AOB. So we've got AOB, where AB is perpendicular to OB. Okay, that is perpendicular to the x-axis, shown below, and determine whether it conforms to the safety regulations. Okay, let's label a few points. A is 30,2 because that's 5, so I'm assuming this is 5. Doesn't really say it, but that's 5, 10, 15, 20, 25, 30. So that's 30 there, and that's 2. The rise is 2. So M equals rise over run. So that's 2 over 30, which is 1 over 15, which is 0.0667 to 3 significant figures. Okay, and this number here is less than 0.08. So that's good. So it did not exceed 0.08, therefore the ramp conforms to the safety regulations. The back of the book has this 0.0833, and it says the ramp does not conform to safety regulations because it's greater than. Question 2, a town website advertises summer jobs for students. A student is trying to decide between a job as a city guide and a job at a flower shop. The job as a city guide pays $40 per day plus a monthly Metro card with a $120 value. The job at the flower shop pays $60 a day. Compare the payments for the two jobs. Complete the table below. Days worked, 1, 5 and 10. City guide, well, it's 160. The way that 160 goes is for the first day, it's $40 a day plus 120. So that's why that's 160. Then when it's 5 days, it's $40 a day times 5 plus 120, and that's 320. And when it's 10 days, it's 40 times 10, or 10 times $40 a day plus 120 is 520. The flower shop is just $60 a day. So that's 60, that's 5 times 60, and that's 10 times 60. Okay, these ones here are the answers from the back of the book here, and that looks good. B, draw the lines representing the payments for each job on the same pair of axes, where X is the number of days worked and Y is the payment in dollars. Now the answer in the back of the book is they've mixed it up. So I've redone the graph here. Number of days worked is the X-axis. Y is the payment in US dollars. And so I replotted these, and the city guide is this blue one here, and the flower shop is the green one. Okay, I just plotted these points here. So we've got 1 and 160 for the city guide. So that's 1 and 160 here. Okay, and I just plotted these points. So I've got 1 and 160, 5 and 320, 10 and 520, plotted that one. And then the flower shop 1 and 60, 5 and 300, and 10 and 600. Okay. C, explain how the student should decide which job to take based on the number of days they plan to work during the month. From the back of the book, students should decide depending on the number of days they plan to work. If they plan to work fewer days than 6, the reason they're saying 6 is because that's where they cross over. That's where the flower shop, you get more money from the flower shop after day 6. And then they should take the city guide job if it's fewer than 6 days. If they plan to work longer than 6 days, the flower shop will pay more and they should take that job. You see, once it gets to 6, the flower shop line is above the city guideline. 3, US roof regulations state that asphalt tiles can only be used for roofs with a minimum gradient of 0.17. The roof shown in the diagram has a width of 7 meters and a rise of 1.6 meters. Find A, the roof run. Well, the roof run is this over the roof run here, because we're looking at the rise over the run. So that will give us that. Now this number here of 7 meters is the width from here to here. So we have to divide it by 2 and we get 3.5. So this green arrow here, that's 3.5. The rise is 1.6. The roof gradient, is 1.6. The rise over the run, okay, and that's 1.6 over 3.5, which is 0.457 to 3 significant figures. C, determine whether the roof satisfies the requirements for using asphalt tiles. Justify your conclusion. Regulations state that the gradient must be greater than or equal to 0.17. Since 0.457 is greater than 0.17, the roof satisfies the requirements. Okay, well, when you read the answer in the back, they write the word maximum, so they really should have written maximum here. That's an error. That should say maximum. If that's maximum, then they are right in the back of the book if they change that to maximum, and it makes more sense that that's maximum because these asphalt tiles are pretty heavy. So if the slope is greater than 0.17, then they're likely to slide down the roof, one would imagine. Okay, so change that to maximum and use the answer in the back of the book to say that they don't satisfy. But if we run it as a minimum, then it would satisfy. Question 4, road signs showing the steepness of hills are often given as percentages, as in the one shown below, where the figure is derived using the formula rise over run times 100%. You've seen these before, I would imagine. A, for a certain road, the vertical change is 5 metres for a horizontal change of 20 metres. Determine the percentage that would be written on the sign for this road. Well, the percentage equals rise over run times 100%. We've got that from here. So that would be 5 is the rise. Horizontal change is 20 times 100. And that equals 25. And I'll just write in percentage there. B, which is the steeper road, the one with the sign indicating 10% incline or another with a sign indicating 15%? 15% incline is a steeper road than 10%. C, determine the vertical change corresponding to a horizontal change of 5 kilometres for a road with a sign indicating 15% incline. Well, 15% equals rise over run times 100%. Therefore, 15 over 100 equals rise over 5 times 100%, which is 100 over 100. 15 equals rise times 20, therefore rise equals 15 on 20, which equals 0.75 kilometres. Question 5, the ski slopes in the Scotch Pine Ski Resort are marked by colour as an indicator of the incline. The colours used are green, blue, red and black. Green is used for slopes with less than 20% incline, blue for 20 to 25, red for 25 to 40 and black for above 40. Now I've rewritten all of this like this, and notice that they've made a common error here where they've got blue to 20 to 25 and they've got red is 25 to 40. So I've changed it a little bit. Incline is less than 20. That's for green. For blue, I've put it's greater than or equal to 20 or less than 25. I've included 25 with the red, so 25 to 40. So that's including, and that's including that. And then they said above 40, so I just put incline is greater than 40 here. Okay, the first one, classify the following slopes as blue, green, red or black. Number 1, P1 with a horizontal change of 450 and a vertical change of 280 that passes through 0, 0. So that's 280 on 450 times 100%, and that's 62.2% in 3 significant figures. Therefore, the slope P1 is classified as a black slope because 62.2 is above 40%. 2, P2 with a horizontal change of 150 and a vertical change of 50 that passes through that. Horizontal was 150 and the vertical is 50, so that's 50 over 150 times 100%. That's a third times 100%. That's 33.3%, 3 significant figures. Therefore, P2 is classified as a red slope. 33.3 falls within here, this one. 3, P3 with a starting point at the top at 310,48 and at the end at the origin, 0, 0. P3 is 48 minus 0 over 310 minus 0 times 100%. That's 48 over 310 times 100%. That's 15.5%, 3 significant figures. Therefore, P3 is a green slope because 15.5 is less than 20%. 4, P4 with a starting point at the top at 230,56. That's the x coordinate, y coordinate, and end at the origin. P4 is 56 minus 0. That's y2 minus y1 over x2 minus x1 of 230 minus 0 times 100%. That's 56 on 230 times 100%. That's 24.3%. 24.3% is blue, therefore P4 is a blue slope. Now there's also a part B and a C. On a pair of axes, graph each line, label it and mark it with a respective colour. So I've taken this from the back of the book, but again, they didn't label the y-axis, they didn't label the x-axis. Make sure you do that, and I've written P1, P2, P3 and P4, and have a look back at the question part A, and you'll see what that means there. C, determine the angle of inclination alpha of the slope P2, so that's P2 there. So basically you want to find the angle between that red line and the horizontal axis. Well, that'll be the tan of that angle because it's rise over run, opposite over adjacent. So the tan of that angle is 50 over 150. We know that's 50 over 150 because they told us in part A that it was a 50 metre rise over 150 run. So that's 10 to the minus 1 of 50 over 150 on your calculator. That gives us alpha. That's 18.43495 degrees or 18.4 degrees. That's the answer in the back of the book.